Hey everyone! In this video, we're going to go over an interesting consequence of how Python deals with magic methods and inheritance. As we saw last week, Python provides a number of magic methods like init and eq, which you can override in your own classes to take advantage of some convenient Python functions and syntax. For example, if we want to define our own classes and then be able to compare instances of those classes using equals equals, all we need to do is override the _eq method. In normal situations, when we override this method and then use it in this form in our client code, then what happens is we take the first object and then call its eq method, passing in the second object as an argument. On line 21, a == b will really call the a.eq method on b, whereas b == a on line 22 will call the b.eq method on a. So when we run this code, the first two lines correspond to calling a.= b and returns false because their name attributes are not equal. However, the second two lines correspond to calling b.eq on a, and this returns true because now we're only comparing the lengths of their name attributes. When we throw inheritance into the mix, something interesting happens. Let's make b a subclass of a. Let's run the code. Whoa, something weird happened. Now we get the same two lines printed out for both a == b and b == a. In Python, even though we normally call the eq method on the left operand, there is one giant exception to this. If the right operand is an instance of a subclass of the class of the left operand, then we actually call the subclass's eq method with the calling object being the right object, not the left one. And by the way, this has nothing to do with method overriding. I could change this code so that inside B, I've actually commented out this definition of eq. Even if I do this and then rerun the code, again, both of these lines are printing out the same thing, where the first message is comparing by and hey, where the by is the name attribute of B and hey is the name attribute of A. And just one last thing. In one of the sections last week, we saw something even weirder, which was if we had an int variable and we also had an A object, and then tried to compare the two for equality, we would still get an error. But this error is pretty weird, because even though we're trying to evaluate x == a, the fact that the error we're getting is int object has no attribute name, we would only ever get this error if we were using the eq method from the class A, not from the class int. Now, class A isn't a subclass of int, so what we've said before doesn't really apply in this situation. However, there is another situation besides just inheritance in which the right operand's eq method will be called. But in this case, the left operand's eq method is called first. When we type in x == a, Python really does call x._eq with a as an argument. When this gets evaluated, a special value called not implemented is returned. And this value is special because in Python, if it's returned from calling a magic method from a binary operator like =, then rather than just returning not implemented, it first calls the right operand's eq method. In other words, returning not implemented is like saying, well, I don't know, but why don't we give the other guy a try? So x.eqa fails, and then a.eqx is called. And this only would happen if the first method call returns this special value, not implemented. Thanks for watching and have a great day.